This program has been made possible by a grant from the UCF Office of Research and Commercialization.
The UCF Office of Research and Commercialization is committed to moving the discoveries of our faculty and students from ideas to innovation to realization. By moving research from the laboratory to the private sector, we are helping to diversify Florida's economy and helping to bring high-paying jobs to our state. This program presents some examples of our research and our efforts to transition this research to the private sector.
Hello, and welcome to another edition of Zenith. I'm your host, Ed Hyland. Today our look at the world of research is pretty far-reaching. We'll hear about advances made in fighting the damage caused from heart attacks by using stem cells. UCF researchers have actually grown beating heart cells. Plus, new discoveries about how the mind works and sometimes doesn't when ravaged by neurological disease like Alzheimer's. And we'll conclude my interview with researcher Henry Daniell. Today he details a breakthrough he's made in fighting disease using plant-based vaccines. We also have news about another Daniell discovery, a way to make biofuel. These stories and much more only on Zenith.
Yeah, I have to disappoint you. It will be the same technology as we drive today. It will be the old combined combustion engine, which we are driving since 100 years, when we are talking about the majority of vehicles on the road and sold. 10 years. And we believe that that engine can be significantly further improved from the technology and from the engineering point of view, and can really contribute also for fulfilling greenhouse gas and fuel consumption standards in a much cheaper way in respect of investment for the industry and for the consumers as well as for alternative powertrains. That does not mean that there is an increasing trend to alternative powertrains. We will see a migration, most probably top-down, so very wealthy people who can afford a car starting from 50, 60,000 US dollars. If you look at Tesla right now, costs about 100,000 US dollars. And they will start to buy alternative vehicles in respect of the powertrain. Right now it looks like that electric battery-driven vehicles do have maybe the major potential of being the future drivetrain for cars. Hydrogen is a bit more complex, but it's a very advanced technology as well, which is maybe then one step behind. I predict it's a little bit looking into really glass ball, that in 10 years we will have approximately 5% of vehicles sold here in the United States will be pure battery-driven electric vehicles. It's my forecast. Can be more, can be a little bit less. but the combined combustion engine will significantly improve. We will have cars which will drive easily 40, 50, 60 miles per gallon here on this old combined combustion engine.
The UCF Business Incubation Program is a university-driven community partnership. Entrepreneur Magazine says Orlando has one of the most highly coordinated entrepreneurial engines in the country, and it all started with the UCF Business Incubation Program.
The goal is to get something out into the marketplace or get something published or patented that really benefits society.
Providing companies with the enabling tools to create financially stable, high-growth enterprises. We hear a great deal about stem cells, their potential and their controversy. But science is finding these cells have the amazing ability to be trained. Researchers at the University of Central Florida are using a unique form of stem cell in an attempt to repair heart muscle damaged by a stroke. The research is years away from human testing, but already the discoveries are giving the medical world new insights into fixing a broken heart. The heart does not regenerate. If it is damaged, other cells must take over. Disease can slowly destroy the heart, while a blocked artery can be fatal within moments. Finding a way to repair the heart is the focus of work in the lab of Professor Henry Daniell. Here, a combination of embryonic stem cells and retrained adult stem cells are being tested in the lab.
If we eat too much fatty food and everybody say, oh, watch what diet you eat, it's a common thing. We generate those models in animal models here by blocking coronary artery and generating a heart failure model in animals similar to the humans. And in that heart attack, there is a dead muscle in which all the important heart cells are dying. And as a result, heart becomes as a hardened area, and heart does not contractile, because heart is like as a pump which supply blood to the whole body. If that area is dead, heart cannot beat and person die due to heart failure. But we are trying here, we are trying to replace those dead cells with a newly generated cardiac myocytes or a heart cell from these stem cells. And we can always show you the video in which we have generated beating heart cells.
It's only a few cells, but they pulse, the same way your heart cells must do. But as dramatic as this groundbreaking research is slow and methodical. What works in animals may not work in humans. For each success, there are multiple failures. Dr. Daniell says he knows he's on the right track, and each experiment teaches them something new.
Just a recent example I can give you in my laboratory is of today. I asked my fellows to put a fibroblast growth factor 8 in the cell culture media and inject the animal with those growth factor. And they were saying, oh, why are you saying that? In fact, somebody in that fellow said, oh, can I throw those plates in the garbage? FGF8 is doing nothing. But today, I can show you right now in my laboratory, the stem cells are beating much faster compared with, there is no FGF8 growth factor in the cell culture dish. So this kind of things are always exciting and give us a new niche to learn that how can we improve the conditions of those beating cardiac myocytes so that we can transplant appropriately in the heart to generate a more beating heart muscle.
Dr. Singla's work also branches into cancer therapy. A drug called doxorubicin, used to treat a wide array of cancers, also has serious side effects, including heart damage. If his work can prevent or reverse that damage, even more lives might be saved. With the recent renewal of stem cell research in the U.S., it's now a question of time.
It may take 10 to 15 years before we will be there.
Professor Singla's research program has been supported by the American Heart Association and National Institute of Health with multiple grants. In a previous Zenith, we spoke to researcher Henry Daniell about his work with plant-based vaccines. His latest discovery has important implications for third world countries. Today we focus on his efforts to create the very first vaccine for malaria and combining it with a vaccine For cholera,
there is no approved malaria vaccine right now, and it's really needed because 2 billion people are exposed to malaria every year, and 100 countries are affected by malaria. 500 million cases every year, 1 million deaths. With whatever malaria drugs that we have, once a fever is developed, there are medicines to subside it, but still 1 million people die. And this is also true with cholera. Last year, or year before last, we saw this in Vietnam. Whenever there is a flood, whenever there is natural calamities, then cholera will be the first disease to show up. 200,000 people died recently. And so is there a vaccine? There is one vaccine for cholera, but it is so expensive that it cannot be distributed at the time of crisis because it's not affordable in those countries where it's where people.
and they don't stockpile it. I'm guessing there's not huge.
There is another
stockpiles of it.
problem, stockpiling, because the way it is made, you have to refrigerate it, you stockpile it, and then it loses its efficacy in 6 months, 3 months, and so on. Even when it's given in its full potency, still children develop immunity only for a couple of years, and then they have to give it again. And our breakthrough here is that the capsules that we made, it's a dual vaccine against cholera and malaria, and we tested this with the highest dose of cholera, and then we there are not good animal models to test the malaria, so we extracted the blood sera and then added the malarial parasite to it, and we were able to kill the entire parasite. Not a single one.
So full immunity,
escaped.
basically.
Yeah. And so, so this is definitely a first malaria vaccine, definitely the first dual vaccine as well. But there are a couple of cases where people have used similar proteins that what we are doing, and then they are trying to move it forward to some very early stages of preclinical trials or clinical stage, so on. But of course, that is still the old system. You know, they will face all of the disadvantages that I explained to you before. So the dual malaria cholera vaccine is our latest breakthrough, and much needed in the world. And we did it both ways, injectable and oral, which we always do because we want to compare with the traditional with the new. And the oral did better than the injectable, as we have observed before.
This seems to be something that would be of interest, say, to the World Health Organization, some of the organizations that are outside the large pharmaceutical companies. Are there options in terms of funding from those types of organizations that may be of some assistance?
Correct. This paper is just coming out, and so we hope that there will be a lot of excitement as soon as this is published. And so you are bringing it to the public. Is another very important way where we can reach the investors and donors. And Gates Foundation is interested in funding some of this, and I still have to convince the Gates Foundation that they have to fund all these clinical trials. Most of the philanthropic agencies want to do something which is readily available, which can be distributed. And in this case, there is nothing available now, and therefore I'm hopeful that the philanthropic Gates Foundation or other agencies will fund this, because this is going to be again low cost, and therefore it's more suitable for organizations. World Health Organization doesn't have that much funding for research or clinical trials, but if we take it, now we have done this in enough number of animals. If we show it even in few humans, a small group of 50 or 100 people, then I suppose that the Gates Foundation or other agencies will step in.
Let's see, you've tackled insulin, anthrax, black plague, cholera, and malaria, and kind of a what's next for Henry Daniell.
We have, my goal has been to tackle the top 10 diseases listed by the World Health Organization, and the top 5 diseases are biothreat agents listed by CDC. So we have done in CDC anthrax and plague, which is our number 1 and number 2, and so we still have a few more pathogens to go. In the World Health Organization, we are now working on tuberculosis, so that is the 3rd pathogen. HIV is number 1, but there is no credible HIV vaccine as yet. Once that is available, then we will be able to use our platform to develop that. Otherwise, it's malaria, cholera, and tuberculosis next. So we are working on tuberculosis. So I will not rest until I finish all the 10. So we have a few more to go.
Well, Henry, we'll have to have you back and discuss it even further in the future. Thank you so much for joining us today. And you stay right there. We have much more straight ahead right here on Zenith.
We are interested in the aging process, and particularly how people age in a healthy way. Because once we understand that, we can actually apply what we learn from there to apply that into the process which is unhealthy, like any age-related disease like neurodegeneration or cancer, because that could open up new treatments. We are focusing in particular on mitochondrial function. So mitochondria are tiny organelles in every cell, and they're very important for energy production. And what happens during neurodegenerative disease like Alzheimer's disease or Parkinson's disease is that this tiny organelle, which produces a lot of energy, is actually becoming non-functional.
We're at a time of great innovations in science and technology. Populations are expanding and global resources have never been more abundant. Yet there are answers to some of the world's most deadly diseases that still elude us. It's the mission of UCF scientists to unravel the mysteries of cancer, cardiovascular, infectious and neurodegenerative diseases and find treatments and cures that will improve and save lives. Several approaches are being used to combat cancer, the world's most dreaded killer. Dr. Khalid is working on a drug to help our bodies fight cancer in 2 ways, by causing the death of diseased cancer cells or by protecting our own immune cells so that they can fight the cancer. Dr. Turkson is researching 2 possible compounds that show early promise of destroying breast cancer. But Dr. Muller wants to beat cancer before it gets to the critical stage by using a simple blood test he's working on that can potentially catch tumors long before they become life-threatening.
We're talking about a test that can be done with a drop of blood, and it's a highly sensitive test that is based upon the immune system of the patient. When there's a small tumor, your immune system responds, and we've identified the antibodies that appear in the patient. I envision this test as being something that's done routinely on a routine physical for everybody.
Nearly 2,300 Americans die of cardiovascular disease every day. That's an average of 1 death every 38 seconds. As we age, the risk of having a cardio event also increases. Researcher Dr. Singler doesn't just want to treat cardiovascular disease, he wants to use stem cells to help the heart mend itself.
In the case of heart failure, the major mechanism happen is the cells of heart are dying due to different processes, apoptosis and necrosis. And our major goal is, first, can we stop those dying cells? Second, the cells which are already dead due to injury, can we regenerate those cells?
Neurodegenerative diseases caused by the loss of cells in the brain affect millions worldwide. There are currently no cures for Alzheimer's, Parkinson's disease, and multiple sclerosis. Their effects can be devastating to patients and loved ones alike.
So my research is focused on to elucidate, to gain a better understanding of the mechanism by which neurons die prematurely in neurodegenerative diseases such as Alzheimer's and stroke. So we think that if we gain a better understanding of the molecular mechanism by which neurons die, that will help us design a better drugs.
Dr. Chan and his team have also found a protein that could help treat aggressive brain tumors in adults, similar to that which took the life of Senator Edward Kennedy. In his on-campus greenhouse, Dr. Daniell, who's researching infectious diseases, is using tobacco and lettuce plants in his quest for affordable and effective vaccines.
I have seen the devastation of cholera, malaria, and various other diseases. So I was determined to work on diseases that affect the globe.
One significant breakthrough Dr. Daniell has made in the fight against diabetes is by producing the insulin gene from genetically modified lettuce plants. The powdered leaves can be delivered in capsule form and may restore the body's ability to produce insulin. UCF scientists are not just gaining a greater understanding of critical diseases, their approach is to make new drugs and treatments simpler to administer and more affordable. So in the long run, they will have a positive impact on world health.
Miss a Zenith program? Or perhaps you'd like to search through several years of programs in our archives? Just head to our webpage, www.ucf.tv. Click on Original Programs and then Zenith. We add a new program every month. The goal of research is to better understand the world around us. Our goal is to be a window to that world. I'm Ed Highland. Thanks for joining us on Zenith.